this is the box. As you've seen the inside, it's a bit scratched, but this is voices from about 1980s.
Time is 24 minutes to 6.
Now, I spent ages trying to get the minutes to sound right, but so far this is the best I can get.
Time is 24 minutes to 6. Time.
If you stop at the wrong point, it doesn't stop talking.
4 minutes to 6.
It's better. I've just got a pick running, sending commands to it, and it just repeats that sentence over and over again, which when I was playing with the software, the time was right. But now it's way out. But if you're into 1980s robotics voices, alarm clocks, then here we go.
Time is 24 minutes to 6.
Hi. Now, this is the chip that's in the black box that you saw earlier. It's the SP0256 narrator speech processor, back from about 1983, I think I've said before. And you know, getting hold of data sheets is quite hard. It took a while to find this one. Actually, it's a 28-pin chip, has a crystal oscillator. Only I don't use a crystal oscillator. I use a chip oscillator with a pot so that I can adjust the frequency. And you only need to use a few inputs. You need to, of course, power and ground, but if you look here, the decimal address of all the data that you need to use only goes up to an address of 63, which means you only need 6 data lines in which to send the data to the chip. You don't need the 8. It's got 8, but you don't need them. You only need 6, which I've used the I think it's the 8th one as the signal for clocking in. And so again, there's the pins. It has an internal ROM, and it's all made up of messages. So to send the word 0, you would send the letters ZZ. The code is ZZYROW, and so you look up on here, and you have to look around for ZZ, and there'll be ZZ. So you send the decimal 43. What was the other ones? YROW. YR is around here somewhere. YR. So again, you send the code 60. I've forgotten the other one already. OW. Look down the O's. It's not in a very easy format to find, but there we go. OW code 53. And then you follow it with a little bit of silence of one of these pauses up here. Depending on whereabouts whether it's the end of the message or in between a word, you use a different value of delay. And I've just got it running on a PIC chip, and here you can see there's the number that makes up the word 0. The code that makes up the word 1. Each one at the end of it, you see, ends with 04, which is a sort of end of word delay. It is a bit wasted. I've got it on all of them, and in reality it really shouldn't be there, because the fact it's on everyone doesn't mean you need to use it. You could put it in the routine that's doing the call and not putting it in the data for the words, and so you'll save a lot of space. And as you can see, each each sort of like day or number is an array of values, and then I have the days, which is an array of arrays. So basically, when you look at Sunday, that points to this Sunday, and it points to that memory location there. So it's all pointer arithmetic, and there's one for days of the week, numbers 20s to 50, and then there's one for time is minutes, and you can see that it's the minutes the one that I'm having problems with, as trying to play around with the numbers to get the minutes to sound right is a little bit difficult. And so then the main just sets up the ports, makes sure that the bit on the port that is pulsed to load the message is high, and then basically it just goes into a loop forever. And there's the pointers to the days, the numbers, the tens, and the words. And it just goes into this loop here, the loop while one, so it loops forever. And it just says play speech, a pointer, 0, p word 0, p word, and it passes the pointer for the number you want. So that's the first in the array, the second in the array. And that gets passed to my play speech routine, and the play speech routine just takes in the point to the array and the size of the number it's going to have, and basically loops round, passing out the first character in the array, setting the bit, clearing the bit, then resetting the bit, so latch it into the chip, wait while one of the inputs is low, as soon as it goes high, go around again, load the next one in. Once it's loaded all the data in for that word or sent that word, it then drops out, and of course comes back to the one down here, and it says the next one. So we've basically got time is the numbers 2 and then some numbers, and so basically it sounds a bit like, if I run it,
2, 6, time is 24 minutes to 6.
and that was the overall effect. A bit quiet this time, so I've turned it down. But I thought that it would be interesting to see how you make the words up, what they've been made up for and how they were made up. It is difficult when it comes to you're using words that are in here and they sound reasonably good, but when you want a word that's not in here, like minutes, there is a word for minute, there's the data for the word minute, but to put the S on it is difficult. And I was trying to use upper words where there are like speller and spellers, and even trying to mimic what they do at the end of the word to make the plural sound doesn't work properly. It's all to do with how the voice box works, because that's how it works. And if you know what these are, voiced, voiceless, all these different resonance and was it nasals and not, it's an old chip, there isn't much around on the internet, and I have big problems trying to convert these types of sounds into a meaningful word. And so I think that basically sort of covers what I was going to say on this. and hopefully I shall move on to putting the clock on. Sorry about if you get these fans in the background. The power supply fans are kicking in and the scope's got a fan running as I've been up here playing. But no, I think that's it, and I'll catch you all next time.